is going to be n times x raised to the n minus 1. So based on that formula, what is the derivative of x to the second power? In this case, n is 2. So it's going to be 2x raised to the 2 minus 1, or 2x to the first power. And so that's the answer for the first example. Based on that, try these two. Determine the derivative of x cubed and x raised to the 4th power. So in this case, n is 3. So it's going to be 3x to the 3 minus 1, or 3x squared. Now for the next example, n is 4. So it's going to be 4x raised to the 4 minus 1, or 4x cubed. And so that's how you could use the power rule to find the derivative of a function. Now what about this one? What is the derivative of x? Go ahead and try that example. So this is basically x raised to the first power. So thus n is 1. So it's going to be 1x to the 1 minus 1, which is 1x to the 0. Anything raised to the 0 power is 1. So we just get 1. Now what about like the derivative of 5x? What's going to be the answer now? If you have a constant in front of the variable, you can move the constant to the front. So this is the same as 5 times the derivative of x. And the derivative of x is 1, so 5 times 1 will give us 5. The derivative of, let's say, negative 7x is simply negative 7. Now what about the derivative of a constant? The derivative of any constant is 0. Now one way that you can remember that is you can write 8 as 8 times x to the 0, because x to the 0 is 1. And so these two, they're the same. So this is 8 times the derivative of x raised to the 0. And using the power rule, it's going to be 0x raised to the 0 minus 1. And 0 times anything is 0. So the whole thing is just going to be 0. So make sure you remember that. The derivative of any constant is always equal to 0. Here's another one. Find the derivative of 9x to the 4th and also 7x to the 5th power. So this is going to be 9 times the derivative of x to the 4th, which is 4x raised to the 4 minus 1, or 4x cubed. And then you just got to multiply 9 times 4. So the answer is going to be 36x to the 3rd power. For the next one, it's going to be 7 times the derivative of x to the 5th, which is 5x to the 4th power. And then 7 times 5, that's 35. So you get 35x raised to the 4th power. Now what about the derivative of, let's say, a polynomial function? 4x to the 5th plus 7x cubed minus 9x plus 5. Go ahead and try that. So the derivative of x to the 5th is going to be 5x to the 4th power. The derivative of x cubed is 3x squared. And the derivative of x is 1. The derivative of a constant is 0. So 4 times 5 is 20. 7 times 3 is 21. And this is going to be it. So it's 20x to the 4th plus 21x squared minus 9. So you just have to differentiate each term separately. Now what about this one? What is the derivative of the square root of x? Go ahead and try that. For this example, we need to rewrite it. This is x raised to the first power, but within a square root symbol, and the index number is a 2 if you don't see a number there. And so the way you rewrite it is like this. It's going to be x to the 1/2. Now we can use the power rule. So it's 1/2 times x raised to the 1/2 minus 1. 1/2 minus 1 is the same as 1/2 minus 2/2. 2 divided by 2 is the same as 1. And so this becomes negative 1/2. So we get 1/2 x raised to the minus 1/2. Now, whenever you have a negative exponent, you need to move the variable to the bottom of the fraction. So we're going to put x in the denominator of the fraction. So the exponent will change from negative 1/2 to positive 1/2. And recall that x to the 1/2 is the same as the square root of x. So at this point, we can replace x to the 1/2 with the square root of x. And so this is the first derivative of that function, the square root of x function. Let's try another radical function. Let's use the 7th root of x to the 4th power. So the first thing we need to do is rewrite it. This is going to be x raised to the 4/7. And now we could use the power rule. So it's 4/7 times x raised to the 4/7 minus 1. So 4/7 minus 1 is the same as 4/7 minus 7/7, which will be negative 3/7. And so this is going to be 4/7 x raised to the negative 3/7. So once again, we have a negative exponent, which means we need to move the variable to the bottom of the fraction. So the 4 is going to be on top, the 7 is going to be on the bottom with the x variable, and we're going to change the negative exponent to a positive exponent. And then at this point, we can turn it back into its radical form. So it's 4/7 times the 7th root of x cubed. Now, if you want to, you can rationalize the denominator, but I'm not going to worry about that in this example. So I'm going to leave the answer like this. And so that's how you can find the derivative of a radical function. Now, what about the derivative of a rational function, like this one? What is the derivative of 1 divided by x raised to the 5th power? So once again, we need to rewrite it before we could use the power rule. So what we're going to do is we're going to take the x variable and move it to the top. And as you do so, the exponent will change sign. It's going to flip from positive 5 to negative 5. So now we could use the power rule. N is negative 5. So it's going to be negative 5 times x raised to the negative 5 minus 1, which is negative 5x to the negative 6. So this is the answer, but we want to rewrite it. Since we have a negative exponent, we're going to move the x variable back to the bottom. So the final answer is going to be negative 5 over x to the 6th power. And so that's how you could find the derivative of a rational function. Now let's talk about the derivative of trigonometric functions. So here are some notes that you need to take down. The derivative of sine x is cosine x, and the derivative of cosine x is negative sine x. Next, you need to know the derivative of tangent x, and that's going to be secant squared. Now, what do you think the derivative of cotangent x is equal to? It's going to be negative cosecant squared. Now, the derivative of secant x is is secant x, tangent x. Based on that, what do you think the derivative of